and varied career has spanned, pardon me, there we go. It's spanned military, private, and federal sectors. As a health physicist and project manager focusing on nuclear facility reactor operations, overhaul, decommissioning, hazardous, toxic, and radioactive waste management, transportation, and disposal, and emergency response and emergency management. Chris has served with the U.S. Army Corps of Engineers as a subject matter expert for contaminated debris management. He deployed to manage earthquake debris during the Haiti Unified Response in January 2010. He served as a technical consultant for oversight work for over $2 billion environmental cleanup work at federal facilities. He served as the Joint Musicians Command Theater Radiation Safety Officer and provided management, transportation, and disposal of radioactive commodities, equipment, and munitions during Operation Iraqi Freedom and Operation Enduring Freedom. He joined EPA's Office of Radiation and Indoor Air as a health physicist in 2016 in the Center for Radiological Emergency and Management, where he serves as a representative to the Advisory Team for Environment, Food, and Health, better known as the A-Team. He partners with other stakeholders on a variety of radiation protection issues, such as developing policy plans and technical guidance for radiological emergencies. He's EPA's representative to the Interagency Nuclear Safety Review Board, which we'll be talking about tonight, the NSTC subcommittees on space weather, security, and hazards, and space weather operations research and mitigation, and several interagency working groups related to space nuclear systems and the development of associated policy. And Chris led EPA's radiological contingency planning efforts for the Mars 2020 mission and staffed the launch of the Perseverance at the Kennedy Space Center. And I'm going to add, Chris, correct me, the Mars work, that was an EPA gold medal. That was for the Mars launch?
Yeah, for the Mars launch, both with contingency planning and for the Interagency Nuclear Safety Review Board work.
And that one involved a somewhat extended deployment during the height of the pandemic, if my memory serves.
Yeah, a lot of things got changed due to COVID, and it was just a rather challenging episode, I think. The joys of interagency work sometimes don't always work well. But that's another story, and perhaps for another day. I didn't know you were going to do the long intro. Sorry about that. I thought you were going to do the short one. So
don't worry.
We've already done like 5 minutes of the presentation. So thanks, John. Are we ready to go then?
Please.
All right, here we go. I'm going to go ahead and try to share this. And there we go. Bam. And please confirm you are seeing the screen. Look good, John?
Looks good.
All right, thank you, Chris.
Yes, indeed.
Okay, so John pretty much laid it all out there tonight, talking about radiation protection and emergency planning for nuclear space launches. And I'll be honest, John, I found that if we go into the Interagency Nuclear Safety Review Board, it's going to be a little bit more lengthy, and I know there's a lot of questions on that. We're actually preparing some materials for that, so I'll go into more details on that. You can hook me in for another presentation on another month, but we're only going to lightly talk about what the INSERB does. We've got a lot of other stuff going on contingency planning, so I'll be covering that. So as John mentioned, I'm working for the Center for Radiological Emergency Management at EPA. This was my bio slide, but I think John pretty much hit everything. A couple of quick shout outs here. Portsmouth Gaseous Diffusion Plant is one place I worked, which is in the news for all the wrong reasons this past week. There's a look at Camp Air of John in there. And some of the policies that I've worked on, NSPM 20, National Security Presidential Memorandum 20 for launch of space nuclear systems, Space Policy Directive 6, and some executive orders and stuff. And there's a roadmap that should be coming out soon. It kind of died a little bit at OSTP, but hopefully we'll get that published soon. And then down in the right-hand corner, my darling wife and our 2 dogs. So we have furry kids. Next slide up. I'm going to cover the Mars 2020 mission overview, contingency planning for it, how things went on launch day, which things never go as planned, and what are the next missions. And those are actually pretty cool. So for the mission overview, I don't know how many of you have actually looked into this, how intrigued you are. I'm fascinated by this stuff. You know, if they had a great HP job at NASA, I might go there. Unfortunately, I think I have the best job in the world where I'm at, so I'm not going anywhere. So what are they looking for? What's the mission all about? Well, they're studying the geology, the astrobiology. They're taking samples, and they're going to have another mission come by and pick those up in about 10 to 15 years, preparing for human exploration, doing things like making oxygen. They managed to make 6 grams of oxygen per hour using the onboard system for this rover. The launch occurred on, let's see, July 30th of 2020 using an Atlas vehicle. It arrived in February 2021. I believe it landed on February 28th. It's really a pretty cool mission. You think about how far it has to go, and then you think about, wow, how is all this going to get powered? Well, here's the actual rover itself. There was quite an international effort in putting things together. NASA likes to be really collaborative, especially for these big showcasing type of endeavors. The thing to concentrate on there is this, plutonium power supply right up here. It says MMRTG. That's a multi-mission radioisotope thermoelectric generator. Basically a big old pile of plutonium marshmallows, plutonium-238. Just sitting there kind of on simmer, providing some decay heat, which then gets changed into, or using thermocouples, becomes direct current. So it puts out about 2,000 thermal watts and over 100 watts direct current. So this is a pretty nice little power source. They're looking at one in the future that's going to be twice the size of it. That's a cool mission I'll tell you about later. But that's essentially what's providing electricity to the rover and actually maintaining some heat. Next up, here's a closer look at that MMRTG. 768 thermocouples. They're coming out with a new version that has more high tech as far as the thermocouples go. So they'll be able to pull more heat off. They might also double this. Right now, this model has 32 little marshmallows in it, basically 8 graphite or general purpose heat source modules. And each one of those has 4 of these marshmallows just kind of sitting there cooking. And yes, they do glow red. The whole thing is about 10.6 pounds of plutonium. And yes, this is the thing that Mark Watney was told not to dig up on Mars, but he did. Except that was from a previous mission. And these have been pretty much standardized over the years. There's some pretty cool features to them. I will note that safety is kind of built into their designs from day one. Early on, they had one of these radioisotope thermoelectric generators come back to Earth and kind of burnt up in atmosphere. And it actually ended up depositing a crap ton of plutonium in the atmosphere. It wasn't a good look politically for the United States, so they changed their process because at that time they were actually utilizing Earth's atmosphere to burn it up. In other words, it was on purpose. But again, they got some negative flack on that, and they decided to make it more survivable and even for recovery. So what they did was little things like ablation is a key factor. So you don't want to maintain a single leading edge. So they put these little notches inside the general purpose heat source modules. They're on the outside, and they made them kind of a funky shape so that it's going to tumble when it comes back into the atmosphere. And that way it doesn't maintain a leading edge. And so you're less likely to have ablation that would uncover the marshmallow. And the marshmallow itself is encased. I think I've got a good slide for that coming up here. Nope, I left that one out. Sorry. It has a really nice ductile metal enclosure on it, typically iridium. Previous ones included gadolinium. So there were, different options, so to speak. The idea is that you want that metal to be ductile and flex, because if you have a physical shock, you don't want it just cracking open like an egg. So the idea is that at the temperature that it sits there and just kind of simmers, we want to maintain ductility in those metals. So a lot of really cool things that they have going on here. A safety design feature here is putting that MMRTG in a position that's kind of farther away from that really highly energetic rocket fuel. That's really one of the biggest dangers there. You're going to have the potential for a combination of physical insults, fire environment, anything that you could think of really for a rocket launch. You could have a really bad day would be if you have what they call a full stack impact event, where the rocket basically collapses down on itself, and you end up with that MMRTG in the middle of a blazing fire along with all the rocket boosters. And yeah, that's a really bad day. So basically what we did is we took 10.6 pounds of plutonium-238 and stuck it on top of one of the world's largest Roman candles with over 1 million pounds of rocket fuel. So you go, well, what could go wrong? A whole lot of things. So there's a whole lot of contingency planning that takes place for this. And it goes back to, oh gosh, we started our Interagency Nuclear Safety Review Board process in 2016 for the launch again in July of 2020. We started our radiological contingency planning process. NASA actually started it first for about a year and a half. I think they go back to early 2017. They brought in the other agencies, including EPA, in March of 2018. So we had over 2 years to prepare for this. And one of the reasons we had that safety review board starts up early is because what their product is kind of feeds into how we do our contingency planning. John, I forgot to mention, could you monitor chat for me? And if you see anything come up, let me know. Anybody wants to ask questions as we go, that's no problem.
Got it.
So what the program does, and by the program, I mean, in this case, NASA, who was the mission manager, in collaboration with other agencies, most notably the Department of Energy, their Sandia National Lab, some folks out of Livermore, especially the NARAC group. They also include folks from JPL, as well as Los Alamos, and I'm sure I've left some of them out, but what they do is they get together and they conduct a safety analysis related to the system and the launch and all the possible outcomes that they could have. So what it looks at is a probabilistic risk assessment and uncertainty analysis. And I got to say, there is a tremendous amount of uncertainty built into these. The problem is we haven't really had one blow up on the pad with a nuclear payload on board, like something that we could get actual results from. So much of this is done through modeling. And with every model, you have a great amount of uncertainty, well, more or less in some. But by the time you add them up, going all the way through, your final results are your best guess, and your uncertainty is probably orders of magnitude. But it's the best guess we have, and we use that to base what are our contingency planning actions going to look like based on a bad day, something from a bad day to an extremely bad day. And some of these scenarios that we prepare for could be those 1 in a million types, but at least we have an understanding of how bad a 1 in a million failure could look like. So it goes through all the different accident scenarios and probabilities from the time you load that MMRTG into the rocket up to the point where if you had a return mission, it might come back or inadvertently come back if something goes wrong. It goes all the way through all the phases of launch, orbiting, and then leaving orbit, and again, potentially coming back. It looks at all the different accident environments. What if it goes down in the ocean? What if it goes down on the pad? What if it blows up in midair? There's thermal insults to it. There's physical insults. There's potential chemical insults. So all of these accident scenarios are played out using this probabilistic risk assessment. They look at the hardware that's involved. They do response testing and modeling as well. So they look at, how well does that jacket on the radioactive marshmallow hold up under varying conditions. And then, of course, they calculate what would be the source term. If it is a bad day and this thing comes apart, how much, what's the biologically effective mass that they're going to be releasing? What does that look like? So one of the cool things they do when they make those marshmallows, they make them in a ceramic oxide form, that plutonium dioxide. So ceramic form is really nice because it tends to shear as opposed to creating finely divided particles. And the biggest issues that we worry about are inhalation and ingestion. So reducing the finely divided particles, That's always a goal. So once they've got all those things figured out, they can go through and come up with a consequence analysis. They're looking at atmospheric transport and dispersion. High split is heavily involved there. We look at low altitude releases, high altitude releases, releases from the ground. When you have thermal effects, you're going to get a rise out of that, which could entrain particles and actually bring them up. You look at things like conglomeration. Does that take particles out of the air? There's so many different aspects that get examined there. I would love to be able to share a whole lot more about the safety analysis. Unfortunately, it's not readily available for general viewing. They have basically a controlled, unclassified version. It has export controls associated with it. And really the interesting thing I found when we started this off, there's so many different contractors involved because DOE is a contractor complex. They're all government-owned contractor-operated laboratories, essentially. It took us almost 3 months to get all the non-disclosure agreements signed off by all the attorneys from all the different labs because there was just so much involved. So a lot of the information that would be contained in these are proprietary by nature, and it's not widely shared. In fact, they rarely produce a public version after a launch. If something goes wrong, they might, consider doing it. But generally, they just kind of sit on that information. They share enough to fill out what they call a nuclear risk assessment. And that's to feed into the NEPA documentation that has to be done. And the NEPA documentation was started back, actually it was completed with a record of decision back in 2014. And that was issued down in Florida. When they went through and we went through the process of this safety analysis and a review by the Interagency Nuclear Safety Review Board, which I'll talk about on another occasion, but basically they conduct kind of a review of the efforts that are done by the program to make sure that it's credible. It is not an approval, disapproval, but are they in the right ballpark? Did they kind of capture the range of outcomes and relative risks that are involved? So all of that is going to feed into the radiological consequence analysis. Like I say, we're going to look at exposure pathway modeling, inhalation, both through direct and resuspension. We look at the ingestion. You've got to look at, what are the agricultural concerns in the area. Really interesting thing about this atmospheric transport and dispersion modeling is Florida might not be the first place that actually gets hit by it. It could be the Bahamas. It could be someplace up the coast. It could be your highest dose. You might see it actually in a few instances. It traveled fairly far inland, and we saw like a highest dose, only a couple of millirem projected in Tennessee. So what's going on there is when they did this probabilistic risk assessment, they took 10 years of NOAA data, the last 10 years that they could come across. And they also utilized like the most recent population numbers for, what's in the area to make a determination on where this would hit and what would the dose be. And of course, with a probabilistic risk assessment, you're doing thousands of these runs. So you get a wide variety of outcomes based on that. But, the more runs that you do, the better you come up with a likely outcome, if you will. So finally, we're looking also at the consequences there, dose and health effects, basically latent cancer fatalities, and of course, land contamination. And land contamination feeds our contingency planning. So now I'm going to bust right into the contingency planning here. So the state of Florida and the county of Brevard have primary responsibility for implementing protective measures. That's just standard ICS. That's the way it works. The locals know the lay of the land. Federal government is going to provide recommendations. I'm sure most of you may have heard of our protective action guidance, which is led by EPA, but also involves CDC, FDA, USDA, and that's all part of the advisory team for environment, food, and health. So an incident involving the potential release of radioactivity may require implementation of those protective measures, shelter in place, relocation, things like that. Maybe interdiction on food, agricultural products, potentially other issues that they may look at. So emergency management structure being utilized here integrates the incident command structure, multi-agency coordination, which I'll give you a couple examples of that, and of course, public information and outreach. Those are critical in managing an incident. Next up, where does this all take place? Well, Kennedy Space Center has this really cool place called their Radiological Control Center. And inside there, they bring together all the necessary professionals from all the different agencies. It's staffed by NASA, the Department of Energy, Air Force, the state of Florida. There's all kinds of groups that are in here. Yeah, a whole lot of DOE people for sure. Looking at on the left side here, that's the Data Assessment Center, and it's actually joined to the right side where the Power Management Group sits at. So that Data Assessment Center, that's your field team and control, data assessment, duh. ECAM data analysis, I'll talk about ECAM in just a minute. Looks at the dispersion modeling, projects dose assessment, and then that's where they kind of develop their protective action recommendations. So the Power Management Group, is actually the Primary Authority Representative Management Group. NASA likes nested acronyms. Oh boy. So PMG for short. And that is basically your federal, state, and local coordination center. It's going to deliver the protective action recommendations to the county. So Data Assessment Center goes through the process of developing products that support a decision. We give that final recommendation, if you will, to the county and the state. And then it would formulate and release radiological assessment information to the Joint Information Center, where they would then go out and message it via various means. That includes text messaging within given areas from cell towers, Facebook, Twitter, you name it, it's going to be out there. So the folks that sit in the Power Management Group include the U.S. Air Force because they own the range that they launch from. NASA does not own that range. It's Cape Canaveral. So that's an Air Force installation. At least it used to be, but now it's Space Command. So it's now 45th Space Wing, I think is the name of it. EPA, that was me. I got to sit in on this launch. DOE, DOE is especially important on this one because they're going to lead the initial rollout of the Federal Radiological Monitoring and Assessment Center, or FIRMAC. We partner with them, but EPA has the kind of like the later role, whereas DOE has the initial role. Although we do roll out assets to help fill out the FIRMAC. But it's primarily under the control of the Department of Energy to begin with, because all that early phase craziness, well, to be quite honest, they got the budget for it. They have the equipment, they have the assets that they can bring to bear early on, while the EPA continues to ramp up. Now, we do have folks from our National Center for Radiation Field Operations out in Las Vegas, and they typically hop on the plane out at Nellis, out at the Remote Sensing Lab, and ride on in with them. While we have other vehicles with equipment also rolling in later on. So I'll cover a little more of that in a minute. Any questions so far? Okay, surprisingly quiet, either bored or awed. So environmental continuous air monitors, I promised you I'd talk about these. These are cool. They were developed and tested at DOE's national labs. The brainchild for this one came out of the remote sensing lab out in Nellis. This is really cool technology. It's available and active 24/7. Continuous telemetry data stream. It can be satellite. I think they had both AT&T and Verizon cell networks on there, and they also had Wi-Fi, and they had another network, and I can't remember what it is. Apologies for that. But essentially, anyway you need to stream it, you're going to get that data. Direct measurement of breathing zone concentrations. It's able to discriminate for respirable particle sizes, has a very low minimum detectable activity, can distinguish plutonium air concentrations at near background levels, and can recognize and basically background subtract for radon. Can run off a generator or AC power. These are really cool units and very specific to our needs when launching 10 pounds of plutonium-238.
So Chris, it looks like a couple of questions have trickled in. The one, I guess, goes back a slide asking whether DOE owns the radiothermal generators.
Yeah, they kind of maintain ownership of it. But an interesting thing happens when they transfer it to NASA for actually being installed in the craft. They still maintain a certain level of security. But as far as an accident or incident occurs, if something occurs from that point on, it becomes NASA as the primary authority representative. So while DOE wants their stuff back if something happens, yeah, it basically falls to NASA to kind of lead the effort to recover. Although, as part of the teams that are there, DOE is going to have teams for recovery. Air Force has recovery teams. There's a whole lot more that I'll be showing you later on. But bottom line, yes, they have ownership up till launch, and if it inadvertently comes back to us.
And then the other question that came in, and I guess this relates to the environmental sampling. So do you monitor baseline atmospheric plutonium radioactivity? So if there's an accident, you can compare.
Yeah, these monitors actually are put out about 6 weeks prior to the launch window. So they start pulling all the background information, and then when it comes time for the launch, they can, make the necessary comparison and figure out how much is what we just added to the atmosphere. Any
Thanks,
others?
we caught up.
Awesome. Awesome sauce. So typical field assets that you're going to see at the time of the launch. You've got your ECAMs. There's 26 pre-deployed, and there's your 6-week prior to launch opportunity. They're going to go out there and start collecting data. There's 17 off-site locations and 9 on-site locations. So they negotiate with the community, find locations that are safe that they can put them. So, nobody messes with your equipment, nothing like that to ruin your day. They've got 4 mobile ECAMs, and they're deployed about 2 hours prior to launch. And what they do is they check the weather. Basically, they do a forecast on where the winds are going to be blowing. They're going to set these units up, 2 on-site, 2 off-site, in the general direction that it's expected to, for the wind to be blowing. And then they're going to have off-site field teams. So off-site meaning off the NASA installation and off Cape Canaveral as well. This means that they'll have RADMON, which is radiation monitoring teams, and then 2 3-person mobile ECAM teams, and that's for troubleshooting systems, doing whatever they need to with those units. Next up on the field assets are the on-site teams. So they have 7 2-person radiation monitoring teams, accident site entry and recovery teams. Yeah, that's to get your source term back. 2-person mobile ECAM teams to go around to the ECAMs that are on site. You got your decon teams and medical decon teams. You have field support on site and off site, which are mover teams for the instrumentation and equipment. You got couriers in case sample collection is required. And then you've got rovers, and that's for ECAM and field communication troubleshooting. So one thing being EPA, I like to point out what are the additional assets that EPA has and that could come into play. This is all occurring basically in Region 4 territories. So Atlanta has the lead on it. Some things that may happen, the EOC may stand up, if there is an accident, may activate a radiation task force at the regional level. We have on-scene coordinators, including some that are trained with regard to radiation or kind of have a little more specialty. We have START and ERS contractors. Those are the kind of folks that are currently responding or did respond to the East Palatine incident, railway incident. So we can get contractors boots on the ground within 24 hours. We have a radiological emergency response team liaison and science advisors that we can bring in from the region. And then the regional office of water will address any kind of water systems or potential sources that may be impacted. Now, the cool thing about down in Florida, they don't have a whole lot of water intakes that are surface. Most of them are on wells, or if they do have surface, they also have the option to switch over to wells, which means that they basically have safe drinking water sources. If anything goes wrong, they're just going to be tapping the wells from there on until they get the all clear for surface intake. So that's a nice little note. Another one is NCRFO Las Vegas. I mentioned they help fill out the FIRMAC. They're going to jump on the plane. They've got field personnel and equipment, and they also provide support for planning activities. Let's see some other assets. CREO, or Center for Radiation Information Outreach. They can provide increased staffing for public messaging. I think I skipped that they help support the Joint Information Center. So we typically embed a person there, as well as in Brevard County EOC. And these are folks that are public information officers that are specifically radiation trained. So they get the lingo, they get the nuances, and they're really fantastic to work with. If you haven't heard of them before, it's definitely worth checking them out. So we can increase our staffing across multiple areas, adding science advisors, unified command, staffing that. So an interesting thing, if things go horribly wrong during an accident, I mentioned the PAR management group. They actually become or morph into unified command, because basically what we're doing is putting all the necessary initial elements in play in one room together so that we can execute immediately if an accident occurs. So that's a really cool thing. Now you need more folks, you got back shifts, things like that. So you're going to fill out those capabilities a little bit more robustly as time goes on. So you're going to have folks standing by ready to come in and engage. Another thing we have, a nuclear radiological incident task force can be pulled together. That's largely for interagency coordination. We can support our headquarters EOC because an incident potentially of this scale could be a national level incident, certainly a regional level one, and will require some good coordination at headquarters. NARAL, which is our National Radio Analytical Lab, which is down in Montgomery, Alabama. They have sample processing capabilities. I think last time I was there, they have 53 HIP-Gs, a bunch of other capabilities, and they run the RadNet monitoring, which is 140 locations across the US and its territories, which provide continuous sampling and monitoring of airborne contaminants. And also for exposure rate monitoring. They're upgrading those systems. Not all 140 of them have the exposure rate monitoring yet, but they're slowly working that in funding. And then there's other regions that are going to support the radiological emergency response team, and they may potentially be moderately impacted because, like I said, depending on the weather, you never know where it's going to come out. So they may need to do some sampling on their own. And if you're looking for more information on that, two good resources are the NUCRAD Incident Annex to the National Response Framework and EPA's Radiological Emergency Response Plan. John, I can circulate a PDF version of this, so if anybody wants the links, I got to tell you, Google is just fine. If you put that in RERP, EPA, you're going to come up with a plan. So that was all the planning. We're a large portion of it, but what does it look like on launch day? Because you never get everything going according to plan. Well, what were we looking at? So what were our accident probabilities? Well, this kind of breaks it down pretty nicely. There was a 97.5% chance of a successful launch and a 2.5% chance of an accident. But the majority of that, we figured, this is again based on all the probabilistic the PRA that was conducted and looking at the wide range of outcomes, there was only about a 2.42% release, or excuse me, accident with no release, and only about a 0.04 chance of an accident with some release of plutonium dioxide. So again, you know, there's a lot of uncertainty in here. So you're always going to prepare for that significantly negative outcome. We just don't have the data to say, yeah, that's an accurate representation of what will happen. And we often get additional information that changes our thinking. And as a matter of fact, I mentioned before that the NEPA documentation was completed in 2014 in anticipation of this launch. They actually had to go back in 2019 and reissue an explanation of significant difference, I believe it was, for the NEPA documentation, because they found that based on their updated modeling, some other information that they got, that the negative outcome was probably an order of magnitude or more greater than was originally expected back in 2014. So they did the right thing. They went back out to the public and they said, hey, if we have a really bad day, it's going to be, notably worse, but we don't think we're going to have a bad day. All right. So let's figure out, what did that day look like? Well, we pre-placed some assets, but this was the time of COVID. That was a really big challenge for us. We really had to work around a lot of issues. The Joint Information Center got staffed, but EPA could not forward deploy their people, so they were deployed virtually. So it was actually really beneficial that we were able to engage on all these virtual platforms in order to make this happen. And we had a lot of people on hot standby. So 1 hour, 2 hour notice that they'd have to hop on a plane if something went bad. So our field teams, they ended up being limited to Kennedy Space Center personnel due to COVID. A RAP team from DOE normally fills that out, possibly even 2 if you need it. But the RAP teams were on hot standby as well. So they would have flown in to kind of supplement what was going on. So we had accident site entry and recovery teams, radiation monitoring, and decon. We didn't have that whole robust typical assets that I laid out. It was a little bit slim. So we did end up getting all our ECAMs deployed. Our 26 got pre-deployed, and then the 4 mobiles went out 2 hours prior to launch. So I just want to fill out real quick the EPA roles at launch. We provide that liaison to management, and it staffs the console during the launch and coordinates requests for EPA assets. I also wore the other hat for the advisory team for environment, food, and health. So we actually had a bridge line open and standing by for the A team. I also served as the science advisor to the PMG. So multi-hatted role if anything went bad. Basically, I was an army of one because I ended up being the only person from EPA that got deployed for this. Then the next one, we talked about CREO. They're critical staff for public messaging. They are awesome. So again, virtual at the JIC at KSC and the Brevard County EOC. And then additional assets standing by pretty much all around the country. So these remote standby assets, again, support the JIC, advisory team for environment, food, and health. No, that's not what happened on launch day, by the way. That picture is just what could have happened. The DOE RAP team, FERMAC at Nellis, was on hot standby. Our NCRFO lead was ready to jump on the plane. The Region 4 Senior Radiation Safety Advisor was ready to go. And then we had an EPA OSC standing by as well in case anything got offsite. So here's what it looks like. This is the JIC. It's actually right next door to the Radiological Control Center and the PMG, the Power Management Group room. Next up, this is the Data Assessment Center. Mostly DOE folks there. A few others. I see a few NASA and some other folks, but yeah, a lot of DOE contractors there. Next up, this is the Power Management Group. I'm hiding behind the Snoopy mask in the back row, second from the right. So going around the room there, yeah, you've got 45th Space Wing, EPA, DOE. We have our Public Information Officer, came out of JPL. Bob Hall, who was the primary authority representative for NASA. And then we had NASA headquarters, the state, then FEMA next to him, and the county. And that was your unified command if things got bad. Fortunately, things did not go bad. On launch day, it was successful at about 10 till 8 in the morning. Yes, we had to be reporting in at 1 a.m. So yeah, that was a long night, but we had a nice successful launch, yay. And I have to say, one of the weirdest feelings was kind of a little bit of disappointment that nothing went horribly wrong, because we had just spent like 3 years getting ready for what could have been a significantly negative outcome. And it was like, yay, it launched. Everything was great. And then it was like, crap, nothing bad happened. Now, pack up and go home. That was it. So yeah, it was a good thing. But still, part of me was a little disappointed. I hate to say it. So I want to bring you up to date on Mars 2020 progress and the next missions. So it was a 7-month trip to Mars, going at about 25,000 miles an hour, 300 million miles, landed in February 2021. We said it collected samples, made oxygen. And one of the cool things is it flew Ingenuity. And that's got the little blue circle around it. So basically, they had to come up with an autonomous drone because it had to be able to scan where it would land and figure out if it was safe to land. And we've got a future mission coming up. And what's really cool about it is that next mission is Dragonfly, and that's going to use a rotocopter as well. This one is about the size of an SUV. It's going to be used to explore Titan, which is the largest moon of Saturn. Titan has a gravity that's about like the moon, maybe 1/6 of Earth, but it's like, I think it's about 3 atmospheres as far as density for the atmosphere goes. So it makes it ideal between the low gravity and the high density atmosphere that a rotocopter can be used. And this, again, is a big one. This is the size of an SUV. It's going to use an MMRTG like Perseverance. It's going to be a little more hopped up. Like I said, better thermocouples, maybe even bigger. And the target launch date is going to be June of 2027. That's the whole planetary alignment thing. Right now, they are still funded for it. So we're on track for it, which means sometime in the next year, we're probably going to start our process again for reviewing the safety analysis. And that's on the Interagency Nuclear Safety Review Board. We are getting routine briefs on this, and also for another mission that's going on, and that's Draco. That was originally DARPA. It is now a DARPA-NASA partnership. And it's the demonstration rocket for Agile Cislunar Ops. Basically, they're going to go up there with nuclear thermal propulsion. DARPA likes to do high-risk, high-reward missions. They're going to show that they can use a high-temperature fission reactor using hydrogen for propellant. They're going to go up, just kind of light off the engine, couple of runs. At least that's kind of the mission right now. It's going to be a cold reactor launch is the current plan. So it's not like you've got spent fuel that you're sending up. And it's all going to be done under a 91B permit. So that's kind of cool. Next one up, just to kind of lay it out there, if you haven't noticed, there's currently a race to the moon. There's a whole lot going on this year. India, Japan, Russia, South Korea, United Arab Emirates, and United States all have moon-related missions going on. I think you probably saw we recently sent one up and did kind of like a long circle on the moon. Yeah, we're looking at advancements in science and exploration. Why are we going there? Resources. Helium-3, if you're not familiar with that, that's a good one to be familiar with. The moon has a buttload of helium-3, which is useful in a certain kind of fusion reaction. So it's basically fuel for fusion. And there's a tremendous amount of it on the moon, largely because it doesn't have a whole lot of shielding, unlike it does on the Earth. So the amount of helium-3 on the Earth is actually really quite small compared to what's on the moon. So that's going to be ripe for mining. There may be other, impact craters and stuff that might be ripe for mining as well. And it gives us a chance to check our technology out prior to doing deep space exploration. If it's only a day or two to get to the moon, that's a whole lot better than having someone stranded with a broken piece of equipment on Mars. Because with planetary alignment out of whack, you're looking at potentially a number of years in order to help them out. So if we're going to make mistakes, the idea is make them closer to home. So China is really a big competitor for us. They're laying the groundwork. We're looking at robotic missions that will set in place landers, orbiters, relay satellites. They've already got one relay satellite to the backside of the moon in place, and they're testing their technologies. They're a little behind us on crewing. As long as we maintain our current schedule, they're looking to get up there by 2030. They're going to begin a construction of the International Lunar Research Station in the 2030s with habitability by 2035. So they are pushing forward. Next one, NASA Artemis, and that's one of the things that we talked about, around the moon and back again. Test the Orion module. We're going to simulate a crew. We need to look at radiation exposure monitoring. That is a huge one. You're looking at potential for encountering some significant exposures there. You're going to. And we need to come up with, approaches to overcome that. And I know NASA is looking at that very heavily. And you're talking about stuff, everything from solar winds to intergalactic type, high energy protons and, other particles that just carry like giga electron volt range potential exposures. So the LET for that is just really wicked. So a lot to look at there. Artemis 2, and that could be a whole presentation on its own. I told John I would try to see if I could line somebody up for that. Artemis 2 is carry astronauts around the moon and back. That's 2024. But that is dependent on getting a rocket in play. And a number of years ago, they kind of made a mistake as far as I'm concerned with their timelines. That rocket may not be ready in 2024. We'll have to see. Hopefully they can get that done. And Artemis 3 is to land in 2025, 2026. I would expect that schedule to maybe slip a little. Personal opinion, not speaking on behalf of NASA. So how do you get to power all these missions? Yeah, we're looking to the commercial sector. That's going to be a big deal. I think NASA and DoD would like to get to the point, and other groups potentially would like to get to the point where they can just say, hey, I need a power source of X number kilowatt, megawatt, whatever it might be, delivered to X crater by such and such date. And they're going to go ahead and put that out for commercial, like commercial pursuit. There's a lot of different ways that can be tackled. It could be tackled independently, commercially, like potentially NRC licensing, or it could be done through a partnership. And that partnership could be done through DoD, possibly through the Department of Energy. There's a lot of different ways to do that. And over the recent years, excuse me, there's been changes to nuclear space policy to allow just that. The first one was NSPM 20 back in August of 2019, as well as SPD 6, Space Policy Directive 6. That did a little bit, but yeah, there's a push on for that revitalization of nuclear energy. And they really want the commercial sector to pursue this. And it's kind of a whole flip from where the nuclear policy was at back in like the 1950s, when we were competing with, Soviet Union and trying to get the rockets launched, and we were failing miserably. And so we took all our assets and we put them in one basket. And we said, anybody in the private sector is going to collaborate with our federal sector, which is going to collaborate with the DoD. And they put them all together and they said, oh, by the way, patents are now the property of the federal government. So private sector, if you come up with something, that's ours too. We need all this put together because we need to beat the Soviet Union. Well, fast forward now 70 years. And the idea is that federal sector may not be able to get it done as efficiently as the private sector. So now we're throwing it back to the private sector, engaging by actually providing them certain technologies that they can then pursue in a more cost-efficient, cost-effective manner. I guess we'll see what happens. So we do have some policies that still need to be updated. We don't have standards out there for use of some of these systems, notably like fission reactors. However, we did get together and we had a working group that was initiated by NASA looking at space fission reactor standards. What are the needs? There should be more on that later. John, we can talk if that's a topic for a later date. But those standards are probably years away. You're looking at something like a consensus standard. I would say a la MARSOM. I think MARSOM is a good example of getting a bunch of agencies together. More agencies you get together, the longer it's going to take. But the idea is that we should all agree on, safety protocols when using it, how to evaluate those safety protocols, what does the safety analysis need to look at. All of these things need to be addressed by standards, which aren't in place yet. Disposal, what is the criteria there? Are we going to go back to Space 1999 and maybe make, the moon our disposal facility for all of our nuclear waste? What is the option? What are we going to do? And then who regulates? How do you regulate under those circumstances? So there's a lot left to be answered. So at this point, I'll take any additional questions that may have popped up.
Thank you, Chris.
And
I was grabbing for a mouse that was attached to a different computer there.
And I think I'm spot on at 45 minutes.
Extremely enjoyable. Bill Blakely had another question in the chat. It said, can you comment on nuclear propulsion systems plans and a link to a space on using nuclear materials for space travel?
So nuclear thermal propulsion right now, you could probably just Google up DARPA and NTP. nuclear thermal propulsion. And NASA also, it's kind of funny. NASA was running their own in parallel. They were looking at the technologies. There's nuclear electric propulsion, there's nuclear thermal propulsion, there's, with thermal being the most direct, when you're looking at nuclear electric, you're trading off specific impulse, basically for miles per gallon, so to speak. So, how much thrust do you have versus how long can it go? So there's a couple of different technologies out there, nuclear electric propulsion, nuclear thermal propulsion. Again, NASA had already started looking into this. DARPA decided they actually they came to us and they said, hey, we need to launch. How do we get through the Interagency Nuclear Safety Review Board, blah, blah, blah. We said, we don't have a mechanism for you yet. There was nothing in place. And then NSPM 20 was born and we had a mechanism, but it takes a long time to actually, design, build, and test these systems. So I would foresee that there would be another partnership between contractors and the federal sector to test these systems. Likely locations would include Idaho National Lab. If you think you're going to get messy, there's other places like Nevada Test Site, but DOE might disagree with that. I don't know if anybody from DOE is on board for this call. But yeah, like right now at Idaho National Lab, they're testing Pele, which is about a 5 megawatt microreactor that the Army was actually, per policy directive, charged with testing that microreactor. That was both in Executive Order 13972, and it was also mentioned, I believe, in SPD 6. So the idea, no, wait a second. No, I think it was just Executive Order 13972. So the idea being they're already doing the testing for these things. Another notable partnership is NuScale with their small modular reactors. That's to be tested at Idaho National Lab as well. So that's kind of the testing ground, the breeding ground, if you will, for those technologies. So I'd keep an eye out in that regard. I hope I answered your questions. There's not a whole lot out there right now that's being shared. If you wanted to go back and look at some of the old stuff, I would look up the NERVA rocket and maybe Timberwind.
That's a good segue. Ed, did you want to ask your question verbally? I'll just read it out of the chat. Ed Tupin asked, how did the risk from this mission, presumably Mars, compare to the risk of prior missions using RTGs?
That's a good question, Ed. So when we looked at probabilities of a negative outcome, I think it was fairly similar, excepting that near pad incidents resulted in a larger biologically effective mass release. So it was more on the consequence end. The probability of that negative outcome, I think it was fairly similar, except again, the near pad stuff. It's there. Some things I'm not sure how much I can really talk about in this particular forum. But I would say, we're improving all the time. Our models, we think, are getting better. We're conducting certain testing in order to get a little more proof to those assumptions, if you will. But I think we were pretty much along the same lines, but again, consequences appear to be a little more significant.
Thanks. Jonathan Gill has a hand up.
Hey, John.
Hey, Chris. Just a quick question about the preparations for the Perseverance mission.
Sure.
In Cobalt Magnet 19, which I don't remember.
I forgot to mention that. Thank you.
During that preparation exercise to exercise the FERMAC and associated capabilities for this event, an anomalous event. I know that the A-team sort of came down to strawberry consumption for infants was, I believe, the limiting, I want to say, relocation factor. And I lost I lost sight of some work that was being done in post with the A team on what was supposed to happen with that lower threshold. And I was wondering if
Yep.
you might be able to provide some insight.
Sure. First of all, thank you so much for bringing that up. We actually had a number of exercises. The big one was Consequence Management 19, or Cobalt Magnet 19. That was done in February of 2019 and was pretty much a full rollout, or a good size rollout of the FIRMAC. All the agencies came to play, state, locals. It was really a good exercise. Of course, they specifically set it up to trigger, you know, some concerns that were out there about realism, and especially with agriculture. So funny you should bring that up. Another limiting factor was actually leafy produce ready to pick and eat. So that also included lettuce and things like that. So then the questions started becoming, well, why is this so limiting? Well, because you're saying you're going to get a dusting of this stuff on your produce, and then you're going to consume it. You're not taking credit for washing, and you're saying like you're basically going to pick it the day after it happens. So we actually ended up going back and renegotiating the numbers, because for Consequence Management 19, they utilized their standard dills and fills. Well, one of the challenges there is that when you come to agriculture, FDA was lumping in a lot of your heavy radionuclides, like americium was lumped in with, plutonium-238 was lumped in with, plutonium-239, and all of them were in one category. And then when they do the assumptions for the calculations, they take the most limiting characteristic for any radionuclide in that group and apply it to the model. So where one radionuclide may be something that's very that has a high intake, like it's something that has high mobility in the environment, is soluble potentially, they'll use that when looking at uptake. However, they'll use something else that also has a gamma emission to it when looking at external. So when we looked at ours, we said, the only thing we've got is plutonium-238, maybe a smidge of americium in there, negligible essentially. So what we ended up doing was negotiating very specific dills and fills for the plutonium-238 for the launch. And we signed that off under a memorandum of understanding, which was done very much like, and Ed, you probably remember this, which was done for Mars Science Lab. So in other words, we were no longer limited by that very restrictive number that FDA put in for that radionuclide group. We could be true to the mission and just look at the plutonium-238, its characteristics, its mobility in the environment, uptake, intake, external exposure. What are those factors? So it became a more realistic exercise at that point. And then after we went through that, I do want to point out, we did a command post exercise that was on site only in November of 2019. And then the following spring, we were doing communications exercises as well prior to the actual launch, about 6 weeks prior. Did I answer your question there, John?
You absolutely did. Thank you, Chris.
Okay.
Any other questions? Well, thank you again, Chris, for your time. That's really engaging.
My pleasure.
I'm not sure I'm going to look at marshmallows the same way for a few days, but
they're roughly the same size. So, just
very good.
These ones are a little hotter than what you'll get in the fireplace. Just saying.
Well, thanks again for joining us, and have a great week, everybody.